We're working through some examples involving z-scores, and we're doing it right now. I'm Allison from Math Bytes, and we're doing some examples involving z-scores. So here's our first problem. A sample of human body temperatures gives us a mean of 98.20 degrees Fahrenheit and a standard deviation of 0.62 degrees Fahrenheit. Let's convert these values into z-scores. Now, we'll remember that a z-score is equal to x minus x bar over s. So the data value minus the mean divided by the standard deviation. So let's do our first measurement there. We have 101.00 minus 98.20 divided by 0.62. That gives us, rounded off to 2 decimal places, 4.52. And for our second value, we have 96.98 minus 98.20 divided by 0.62. And that gives us, rounded off to 2 decimal places, negative 1.97. So these are the z-scores for these particular data values. Now, are these data values unusual? We can use our z-scores to answer that question. z1 is greater than 2, so that value would be considered unusual. z2 is between negative 2 and 2, so that value would be considered usual or ordinary. Here's our next problem. We have 2 standardized tests. Test 1 has a mean of 1518 and a standard deviation of 325. Test 2 has a mean of 21.1 and a standard deviation of 4.8. Which is the better relative score? 1840 on test 1 or 26.0 on test 2? We can answer this question by turning these scores into their respective z-scores. So for test 1, we have z1 is equal to 1840 minus 1518 over 325. And rounded to 2 decimal places, that gives us 0.99. For test 2, we have z2 is equal to 26.0 minus 21.1 divided by 4.8. And rounded to 2 decimal places, that gives us 1.02. z2 is greater than z1. So the better relative score is 26.0 on test 2. To learn more about this topic, watch our videos on the Math Bytes with Allison YouTube channel.